Hello everybody, this is Miss Pi obviously. I'm starting the review for your Unit 10 test. There's several questions to it. We'll try to get through all of them. Now with this one, it's all about your sequences and arithmetic and geometric patterns. The first question is, what is the fifth term in the arithmetic sequence with initial term of 2 and a common difference of 3? Okay, so because it's an arithmetic sequence, we need to use this formula here, the AN equals A sub 1, or your first term plus the common difference, times n minus 1. And so because we're looking for the fifth term, we want to find A sub 5, or the fifth term. And our first term in the formula will be, or in the sequence is 2. It gives us that information up here. And then our common difference is 3, and because it says just 3 and not negative 3 right here, then we are going to go ahead and add there. And then the rest of the equation is going to be 5 minus 1. The reason why I use a 5 here is because I'm looking for the fifth term. Okay. When I do that, it equals 14. Honestly, I have no idea what's down here. Yeah, all right. So I should be pretty easy. Most of you are probably already ready for me to move on. The biggest thing is check and see what type of sequence the word problem says. If it says geometric, make sure you're using your geometric formula. If it says arithmetic, make sure you're using your arithmetic formula. All right, moving on. Archimedes used a pattern of squares as shown. Assuming the pattern continues to infinity, what would be the sum of the areas of these squares if the area of the largest square is, the area of the largest square is 3/4. All right, so a couple things that you need to do is figure out what the common ratio is. And this one you need to figure it out visually. So let me show you what I did. Okay, I broke the square down into 4 different sections. Okay, and so this part right here is 1/4 of the big square here. So that tells me, that my common ratio is going to be 1/4. Okay. And I know that my first term is 3/4, so I'm looking for a series. Let me see. Assuming the pattern continues to infinity, what would the sum of the areas be? So I'm looking for the total amount of all the squares all the way down here to infinity. Okay, so that's going to be a series formula. And this is specifically an infinite series formula because I'm going to keep on going forever. So my formula is going to be A sub 1 divided by 1 minus R. Now I've already said that my A sub 1 is 3/4. I get that from right here. And I know that the rate is 1/4 because this square here is 1/4 of this huge square here. Okay, so my common ratio is 1/4. I have that information. I plug it all in. I'm going to simplify, and then I end up with 1. Okay. I know you guys studied the infinite series when I was gone, and I videotaped it. Most of you did not pick up on it. So you might want to make sure you know how to use that formula and when you are going to use that formula. All right, next question. Which is an expression for the nth term of a sequence containing -5, -1, 3, and 7? Okay. First thing we need to do is figure out, do you have a common ratio or common difference? In this case, we find that we have a common difference. We are adding 4 each time. So the difference between -5 and -1 is 4. The difference between -1 and 3 is 4. The difference between 3 and 7 is a positive 4. So in this case, my common difference is going to be 4, and my first term is negative 5. So now I need to put that in my arithmetic sequence formula, and when I do that, I'm going to use my a sub 1 plus d times n minus 1. Well, I know that a sub 1 is 4, and I know that my a sub 1 is negative 5, and I know that my common difference is 4. Notice, though, none of these options are in that format. So I need to combine like terms, or I need to distribute this 4 here throughout these two terms, and then combine like terms. I know we talked about it several weeks ago. So let's go ahead and do that. And when we distribute, we have negative 5 plus 4n minus 4. Go ahead and combine like terms, and your final answer is 4n minus 9. Okay, and then that's my answer. My B is my answer. Okay. All right, next one, which is the 13th term in the expansion of x plus y raised to the 15th power. If you see here, what I have is Pascal's triangle, the 15th row, because my exponent is 15 there, so I'm looking at Pascal's triangle. And if I'm looking for the 13th term, I first need to find my coefficients. So my coefficient for the first term would be 1. The second term would be 15. The third, the fourth, the fifth, 6th, 7th, 8th, 9th, 10th, 11th, 12th, and 13th. All right, so my 13th term's coefficient is going to be 455. Okay, so I know this one is 455 and this one's 455, so I can cancel out these. Okay, now I need to figure out what is my exponent going to be. Let me go ahead and erase these numbers. Okay. Now, for my exponent for x, I'm going to start on this one. It would be x raised to the 15th power, x raised to the 14th power, 13th power, 12th power, 11, 10, 9, 8, 7, 6, 5, 4, and 3. So this would be x raised to the 3rd power. And then I want to verify. So right now I'm going to say it's definitely going to be D, because this one has 455 for the exponent, or sorry, for the coefficient, and then it has x plus 3, which is the term I need. Let's check for y12. Well, this term would be y to the 15th power, y to the 14th, y to the 13th power, and this one would be y to the 12th power. And that is what I have there. Okay, don't forget on how to expand your binomials with Pascal's triangle. Moving on. A new employee earns $32,000 during his first year of work and receives a 4% raise each year. Which of the following could be used to determine the total amount earned by this employee for the first 5 years? All right, so notice I don't even need the answer. I just want to know what sigma notation I'm going to use. So a couple things we need to know. His salary, and this is his first year. We need to know how much he gets in a raise each year, and we need to know how many years we are adding together. Okay, so we're adding 5 years together, so the 5 should be up top. Notice that all of these have 5s up top, so that's correct for all of them. I want to know the first 5 years, so notice all of these have n equals 1, so that checks out on all of those. Oops. And then I have 32,000, checks out here and here, here and here is correct. And then let's look at the interest rate. So he's getting a raise of 4% each year, and we want to know his total salary, total amount earned. Okay, we are looking for the total amount earned. So if my rate was just 0.04%, that would be just the amount of interest, or that would be just the raise amount. It wouldn't be the total annual salary. I need to have my rate be 1.04 to get the total salary. So look at this. This one has the wrong rate. This one has the wrong rate. So it's definitely not D and not C. Okay. Now we look at A and B. Notice the only difference between those is this one just has an N. This one has N minus 1. When I was grading your guys' papers, I know several of you would just leave it as N here. That's the wrong way to do it. Your formula should be N minus 1 here. Okay, so in this case, B is the correct solution. All right, it's the correct formula. All right. Suppose you were given a true-false test consisting of 10 questions. What is the probability that you will earn at least a 70% on the test by merely guessing? All right, this is our binomial probability formula. And let me see, what did I put here? Yep. So this is my binomial probability formula. Remember this N, or parentheses NK, that's your NCR. Okay, or I'm going to put K. If you're typing that in your calculator, you would pull up the NCR, and then some number for N, comma, number for R, comma. Okay, remember, you also could just look at your Pascal's triangle to find the terms that you would use there. And so a couple things we need to know. We need to know what your N value is, your P value, and your Q value. Okay, so in this case, N is going to equal 10 because there are 10 questions. Whoops. Let me see. Yeah, N is going to be 10 because there's 10 questions. Your probability of being successful, well, it's a true-false test, and so there's only 2 answer choices. And one of them is going to be the correct answer, one's the false answer. So you have a 50-50 chance of getting the right answer, or a 0.5 or 1/2. Okay? So your probability of being successful is going to be 1/2. Well, K, to find your K value, it's 1 minus your P value. So 1 minus 1/2 is still 1/2. So this one's an interesting one. You're going to have the same rate for your P value as you do for your Q value. Now, notice for this one, we want to earn at least a 70, or we want to get a 70 on our test. So if we get a 70 on our test, that means I have to have 7 correct answers. Okay, the way I know that is because if I have 10 questions, then each question is worth 10 points, and if I get a 70, then that means I have 70 correct answers. So my I have 7 correct answers. So my K value in this case is going to be 7. Okay, so now that I know all those values, I'm going to plug them all into my formula, and I put it in just like that. Remember that to get your exponent here, it's whatever your N value is minus your K value. And this part here, if I was going to put that in my calculator, I would put it as put NCR 10, 7, and then I put in the 0.5 raised to the 7th power and 0.5 raised to the 3rd power. So when I do that, I get the answer 0.117, and notice, depending on the way you set up notice these are all percents, and some of you might say, hey, this is the right answer because 0.117 rounded would be 0.12. Okay, but notice you have a point here and the percent symbol here. When you're doing percents, you need to move your decimal over 2. And so the correct answer, we're moving the decimal over 2 to make this percent. And so my correct answer would be 11.7%, which is A, not C. Okay. Moving on, which of the following sequences can converge? Okay, this one you need to figure out, do you have a common difference or a common ratio? And then you need to figure out, plug in some really big numbers for n once you figure out your formula, and then see what happens. Okay, so we're going to take this one part at a time. So let's first look at A. With A, I'm adding by 1 each time to get the next term. So my common difference is 1. So if I wanted to find A sub 10, then notice that my A sub 1 equals 0. Notice I don't have a 0 plus my common difference because adding 0 to anything does not change my value, so I just left that off. So if I'm looking for A sub 10, I plug in 10 for n, and I get 9. Easy, right? Well, let's plug in 100 for n. I do that, and I get 99. Does it look like my sequence is going to keep on continuing to positive infinity, or does it look like it's going to reach some point and not move on? Okay. Hopefully you remember from your notes that when it says converge, that means you're approaching some number. You're getting closer and closer to some number, and you're not going to go past that number. Okay. All right. Sorry, let me go back. So we know that in this case, we're just going to keep on going to positive infinity. Okay. We're not going to approach some number and stop. Okay, let's look at our next one. This one is for C. For those of you that realize it, this is a geometric sequence. And the way I've created my rate is I took 3 divided by 2, and that gave me 1.5. And then I wanted to check it, so I did 4.5 divided by 3. Notice I'm taking the the third term divided by the second term, and I still get 1.5. So my rate is going to maintain the same the whole time. And so I have my rate, and I want to find what is my 10th term in this sequence. So my first term is, my A sub 1 is 2, my rate is 1.5, and then raised to the power of 10 minus 1. I plug all that into my calculator, and I get 76.89. Okay, now I want to know what is A sub 100. So do the same thing, except my n is now 100. I plug that in, and I get this really weird number here. Okay, what that means is that's my scientific notation. So I have 5.42 times 10 to the 17th power. So that means I need to move this decimal over 17 times. And so I move it over 17 times, and it gives me this huge giant number. Okay, so does this look like my sequence is going to approach some number, or is it going to keep on expanding to infinity? In this case, it's going to keep on going forever until we get to positive infinity. Since we can never get there, this one does not converge. So it's not A and it's not C. Let's look at D. So this one is a common difference. So I'm subtracting by 0.5 each time to get to the next term. And some of you might say, well, eventually this is getting to 0. Well, you want to check that. Let's see if it does get to 0 or if it keeps on going past 0. So my first term is 24, and I'm looking for my 10th term, and I find that the 10th term is 19.5. That's awesome. Let's put in 100 in for my end value. Oops, this is a typo. In the calculator, I did put 100 there, not a 10. Excuse me. And I do all the calculations. Notice I have negative 25.5. So it's not stopping at 0 like a lot of you want to assume. It's going to keep on going to negative infinity. This does not converge. So that leaves our last one, part B. Most of you probably looked at it originally and said, hey, it must be B, because your rate here is 0.5. To get that, we did 2.5 divided by 5, and that gave us 0.5. You could also do 1.25 divided by 2.5. Remember, you take two consecutive terms. You take the second one divided by the first one to find your rates with geometric sequences. And so this time my rate is 0.5. Okay? I find my 10th term, and I get this number, 0.009766. Then I want to find my 100th term. When I find that 100th term, again, I get scientific notation, but realize I have a negative there. So that means instead of moving the decimal over this way 30 times, I'm going to move the decimal over this way 30 times. Oh, I just saw another typo right there. That should be a 30, negative 30. Sorry. All right, so I take that decimal, move it over 30 times. Wow, I am really bad with this. This should be 7.88. Sorry about that, guys. Times 10 raised to the negative 30 power. So I get that decimal. It was here. I move it over 30 times. It's all the way over there. If I say round to two decimal places, you're going to tell me that the answer was 0. If I say round to, I don't know, if I say round this one to two decimal places, it's close to 0. It's 0.001. So in this case, I am approaching 0 every single time. So this is the one sequence that will converge. One thing that will point out sequences that converge, it has to be geometric. Okay, and the rate has to be greater than 0, but less than 1. Okay, any sequence that is going to converge, well, any sequence and series that will converge is going to be geometric, and the rate has to be between 0 and 1. All right, moving on. Find the limit of the sequence defined by 3n divided by 2n minus 1. Okay, now this one is not geometric, it's not arithmetic, but it is going to, this series is going to converge, or sorry, no, the sequence is going to converge, and we want to know what number is it going to get close to. So basically what you want to do, plug in really big numbers for n. Okay, so you have n, we're going to just plug in some big numbers for n, and let's say we plug in 1,000, okay? 3 times 1,000 divided by 2 times 1,000 minus 1, okay? That answer gives us 1.50075. So now let's add a couple more zeros to our n value, okay? So 3 times 10,000 divided by 2 times 10,000 minus 1, and that gives us the answer 1.50008. Notice how, whoops, forgot I was in the, all right, notice how my zeros are increasing. Here I only had 2 zeros, now I have 3 zeros. So I'm getting closer and closer to some number, and that number is 1.5. Okay, so when you have this type of question on your test, just plug in really big numbers for n to figure out what number are you getting, or what term you're getting closer and closer to. All right, which is the series in the summation notation for that? All right, so we have the terms in the sequence, and we need to figure out basically how many terms we're going to have, because notice some of these say 8 up here, some of them have 7 up here. So how many terms are we going to have, and which formula are we going to have? Okay, so in this case, I used the formulas to find, I used these formulas to find the sequence, the terms in the sequence. So the first one, I have n squared minus 2. Remember how to use your sequence thing in your calculator. So just, you can either type in SEQ parentheses or you can pull up the sequence option in your catalog. So we have SEQ, open parentheses, my equation, comma, the n value, which tells the calculator what your variable is, then your starting point and your end point. Now notice on all of these, my end point is 8 because I want to know, is this the 7th term or the 8th term? Okay. All right, so I do it for, let's see, this is for A and B here. And for A, I get -1, 2, 7, 14. So I have the -1, but not the 2. So A is not the correct answer. For B, I get 0, 3, 8. So B is not the correct answer. Let's look at this one. Let's see, here's C. And then here's D. Okay. For C, I get -1, which is good. I have 5, 15, 29. These are all good. And 125. So that is 1 term, 2, 3, 4, 5, 6, 7, and 8. So I now have 8 terms. And so C is the correct answer. Okay, if you do this check for D just in case, you notice that these are the wrong options, and so D is not the correct answer. All right, number 11, which of the following is a convergent infinite sequence? We kind of already covered this. It needs to be geometric. And the rate has to be between 0 and 1. So how do we know if it's geometric? Notice none of these say it's arithmetic or geometric, but geometric has a ratio, not a common difference. So this is not the correct answer, and that's not the correct answer. Here's your ratios. Which one of these is between 0 and 1? Well, option B is between 0 and 1. Okay, next one. An auditorium is designed in such a manner that an additional seat is added to each row. If the theater has 46 rows and the last row contains 56 seats, then how many people could be seated in the auditorium? All right, so if we're adding 1 to each row, and we know that, oh wow, what the heck did I do? Let me see something super fast. All right, let's see. So it is an arithmetic sequence. I forgot to cover these up. I have no idea what my A sub 1 is, right? But I do know that I have a total of 46 rows, and I know that A sub 46 is 56. So now I'm going to solve, or I'm going to figure out what A sub 1 is. So I'm going to plug in 56 there. I plug in 46 for the n value, and I know that 1 is my common difference because I'm adding by 1 each time. I combine like terms, subtract, solve for A1, and I find out that A1 equals 11. Okay, so now I need to put this in sigma notation. So 46 is going to be my number up top because that's how many rows I have, and 11 is the first term, so I put 11 first, and then n minus 1 and 1 there. So really you just need to know how to set up your arithmetic sequence and how to use sigma notation. So when I get that, I get 1,541, which bam, it's right there. Now, I have noticed that some of you guys will try to use this series formula. This is the series formula. Okay, so if you put your n here, the number of rows you have is 46, your first term is 11, and your last term is 56. Okay, so if you do use your series formula, you also get 1,541. So not a problem. You can use either sigma notation or your series formula. Either one will work. But I've noticed that some of you tried to use sigma notation with the series formula. Notice you get the wrong answer there. You cannot combine those two. It's either sigma notation with your sequence formula, Quence, or it's your series formula. You can use either of those. Don't try to combine them. Lots of you have tried to combine those. It doesn't work that way. Next one, what is the fifth term in the geometric sequence whose initial term is 128 and a common ratio is 1/2? All right, so pretty easy. Your geometric sequence, your rate is 0.5, your a1 is 128. Plug that into your geometric sequence formula. There you go. Type it all into your calculator. It'll give you the correct answer, and it's 8. So B is the correct answer. Whoops, forgot that I did not have the pen. There we go. Easy. Use the following information to answer the last two questions. Suppose you go to work for a company that pays you 1 cent for the first day, 2 cents for the second day, 4 cents for the third day, etc. Which explicit formula would best fit this pattern? All right, so you're doubling your rate is 2 because you're doubling your pay each day. You need to know your a1, your first term, is 0.01. Notice all 4 of those options have 0.01, and they have a rate of 2 here and a common difference of 2 there. So which one of those will work? Wow. D and B are just weird things. Oh, that's D and B are recursive formulas, okay? We want the explicit formula, not the recursive formula, okay? So just kind of cross off these two options. Those are recursive, not explicit. And now I need to know, is it geometric or arithmetic? Well, this is arithmetic, this is geometric, and in this case, my rate is it's not my common difference of 2, okay? I'm not adding 2 each time, I'm multiplying by 2 each time. So my correct answer is C. And then for number 15, if your wage keeps doubling, then what would be your total income after 30 days? Okay, honestly, I have no idea. I did not calculate this out ahead of time. So do your sigma notation in your calculator. It would be n equals 1 here, 30 here, and then use your formula, the 0.01 times 2 raised to the n minus 1 power. Let me do that in my calculator super fast. Okay. Let's say you don't have your sigma notation option. You could always use your series formula. Let me see, what is the series formula for rate? It's your a1, which is 0.01, times 1 minus your rate, which is 2, times n, in this case n would be 30, divided by 1 minus 2. Okay, either one of those formulas can be used. Because most of you don't have the sigma notation option with you, go ahead and use your series formula and see if you get the same answer as I do. Times 2 raised to the power of n minus 1. There's a 30 there. All right, I get... my answer on this is 1.0737 times 10 to the 7th power. So that means I need to move this over 1, 2, 3, 4, 5, 6, 7. So, you know what? I don't even need to actually count those because not a single one of those start out as 10,737 except for C. So I know that that is my correct answer. Now, so these are all the review questions. These there's there's going to be an opportunity to earn 3 bonus points, or to have 3 bonus questions. I'm going to go through these super fast because I know this is a pretty long video already. So here's one. You have x plus y to the 12th power. This is the 12th row of Pascal's triangle, and I set it up. Remember, when you're doing your exponents, you'd have x to the 12th power, to the 11th power, to the 10th power, to the 9th, 8, 7, 6, 5, 4, 3, 2, and 1 here, and then this would be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1 there. Okay, so that's one example of one of the bonus questions. Here's another one. Notice this time I have a -5 here, and so I need to multiply all those out after I figure out all the exponents. This one is going to have an exponent of 3 squared and 1. Then this would be to the 3rd term, squared, and then a 1 there. Don't forget to combine like terms, so your final thing would be x cubed plus, let's see, no, it would be -15x squared. And then, let's see, 25 times 3 is 75, so plus 75x. And then, let's see, 25 times 5 is 125, and that's a -125. Okay, don't forget to multiply everything out. Last bonus option is this one. And again, make sure you do your exponents: 4, 3, 2, and 1. And then 4, 3, 2, and 1. Don't forget to multiply all your numbers out. I'm going to let you guys multiply them out on your own, so I can go ahead and get started with class. All right. Have fun. Watch this. Take notes. You will have a formula chart that you can use on the test with Pascal's triangle. You might want to take notes on this, and I will see you on Tuesday for the test.